Another thing we can use to help us decide what our rational function is going to look like is to look at the horizontal asymptote. Whereas the vertical asymptote cannot be crossed, the horizontal asymptote is really thinking about what's happening at extremes. What's happening when x goes towards negative infinity or positive infinity. Whereas you can never cross the vertical asymptote, a horizontal asymptote can be crossed. We are just looking at what happens to the graph at extremes. Okay, horizontal asymptotes really are a matter of the degree of the polynomials that are being divided. For example, if I think about the first problem, y equals 5 over x minus 7. As x gets towards 10 million, you get 5 over a very, very large number, which becomes a very small number close to 0. Well, what about when x is negative 10 million? You get 5 over a very, very large negative number, again going towards 0. So if the degree of the denominator, if the degree of the polynomial in the denominator is greater than the degree of the polynomial in the numerator, your horizontal asymptote will be at y equals 0. And why is this? Because you're talking about extremes. When x is a really large number, you're getting 5 over a really large number. This whole value gets very small. It goes towards 0. So once again, when the degree in the denominator is greater than that of the numerator, your horizontal asymptote tends toward y equals 0. In this next case, notice that the degree of the numerator and the denominator are the same. So when you plug in 10 million in the numerator, 10 million minus 3, by the time you get to 10 million, that's pretty much around 10 million. And here, 10 million minus 5, when you get to something that big, is around 10 million. So this fraction tends to go towards 1/4. Well, where does the 1/4 come from? The 1/4 is really the ratio of the coefficients of my x term here. The degree of the numerator is equal to the degree of the denominator, and therefore the horizontal asymptote is really the coefficient of my highest degree terms. And in this last situation, if you think about it, when I plug in 10 million minus 8 cubed, I get a really, really large number, right? And so when I plug that in versus 10 million plus 10, it looks like I'm getting around 10 million squared. But if I plugged in 10 billion cubed over 10 billion, you know what? It doesn't seem like there is a limit to what's going on. If the degree in the numerator is greater than that of the denominator, there is no horizontal asymptote. Remember, horizontal asymptote is a matter of extremes. I am looking when x goes towards positive or negative infinity. And so to find out what your horizontal asymptotes are, you're really looking at the degrees of the polynomials in the numerator versus the denominator and assessing whether the horizontal asymptote is at 0, whether it is the ratio of the coefficients of the highest degree terms, or whether there is no horizontal asymptote.